Okay, in this video, we're going to explore some of the different methods for charging. We're going to look at two main methods for charging, but then we will talk about a third method that it's not technically considered a method of charging, but most people, I would think, would consider that is a way that you could get something to be charged. The first method is really simple, and I'm sure you've done this before yourself, that's called charging by friction. Charging by friction is essentially something that is caused by the triboelectric effect. And all that simply means is that different atoms in different materials like to either gain electrons or they like to lose electrons. Now, if you take two materials that both like to gain electrons and you rub them together, nothing's really going to happen because neither one of them really is willing to trade with the other one because they're both looking for the same thing. Where the triboelectric effect works the best is when you have two different materials, like let's say plastic and wool. Wool likes to give up electrons and plastic likes to gain electrons. So when you bring them together and you rub a little bit, they will produce a charge. Each of the objects will gain charge by stealing from each other. Now your hands, when you rub them together, you don't get much of a charge on those because of course your hands are the same material. So whether they like to gain electrons or whether they like to lose electrons, doesn't really make a difference. It's the same material. So in order for charging by friction to really work, you need different materials. Materials that like to gain versus a material that likes to lose electrons. So to give you just a quick example, let's say that we had a plastic box and I rubbed on that plastic box a piece of wool. And this is plastic. So if I take that piece of wool and I rub the thing back and forth, what's going to happen is some of the electrons from this are going to get stolen by this because this plastic really likes to gain electrons. So that after rubbing the two together, when I separate the two of them, what I will end up with is two objects which are identically charged but have the opposite charge. Where did these four charges come from? They came from this guy. So whatever this guy lost, this guy gained. So they both have the same charge. I would say this has a +4 charge. I'd say this has a -4 charge. And when I add the two together, I still have a neutral object. So nothing has been gained or lost. It's just there was a little bit of trading going on, a little bit of internal trading going on between the wool and the plastic. And all of these things that I'm going over here will be shown in demo videos, in supplemental videos I'll show you. I'll actually take some objects. So instead of just drawing diagrams, I'll actually charge some objects up by friction, and I'll show you that they are charged by friction. You don't necessarily have to rub the objects together. So for example, if you take a piece of cellophane tape, by which I'm talking about like Scotch tape, and you were to put it down on a surface that was nice and dry and then pull it up very quickly, you would actually find that it would pick up charges, and that's also the triboelectric effect, but it's not really charging by friction. It's a similar related thing. It has to do with the triboelectric effect, but without the rubbing. Now that's a direct form of charging. That's the most common way things that become charged. My car becomes charged by driving because of the friction with the air. And so oftentimes in the winter, I'll find that when I get outside of the car and I touch the metal part of the car, I get a little bit of a shock. It's not because I picked up any charge, it's because the car, as it rubbed against the atoms of the air, it pulled off electrons from them. And because they were not able to leave the car, they did not leave until I touched them and I allowed them to escape the car. That's a direct method of charging. Now, an indirect method of charging, which is called induction, is a little complicated. I'm going to go through step by step. I'm going to show you one example of charging by induction, and then in the supplemental videos, I will show you another way of thinking about induction using something called an electroscope, which I haven't brought in yet. So for this one, we're going to stick with the pith balls that we were talking about in all of the previous videos. But this idea of doing the charging by an indirect method, this idea of induction, when you induce something to happen, it means that you made it happen indirectly. So for example, let's say if I'm sitting in the classroom and I just need all the students to leave right away. It's just like some emergency and I just need everyone to leave right away. I could tell everybody, hey, I need everyone to leave right now. That's directly. I am directly getting the students to leave. Now, on the other hand, I could not say anything and I could release a tiger at the back of the door. Now, if I release a tiger at the back of the room, I should say, I won't even have to tell the students to leave the room. They will just leave the room just out of fear. So I would say I induced the students to leave the room by letting a tiger go in the back of the room. So induction means somehow getting something to be charged without ever actually using the charged object. So I'm going to draw this in 4 steps. I'm going to go in this direction, 1, 2, 3, 4. I'm going to label the steps and I'm going to put a box around them just so that you can keep straight the order of how everything happened. So in step 1, we're just going to take 2 pith balls. These are neutral pith balls. And we would draw the charges so that they are evenly distributed, right? So what I'm trying to imply to you is that they are neutral objects. They are not charged objects. At least they're not charged right now. Now, in order to induce the charge, I do need to bring a charged object in. But unlike in a direct method where I might touch the objects and pass some of the charge onto them, instead, I'm just going to bring the charged object nearby. So this is a plastic rod, and I have rubbed it against some fur or some wool, and so now the object is charged. Now, the 2 pith balls that are still sitting right there in contact with each other, this is super important, they are touching each other. What is going to happen is that because the pith ball has a conducting surface, the free electrons are going to be able to move away. They don't like to be near this guy. So as this guy comes close by, the electrons are going to want to move over here, while meanwhile the positive charges are going to be over here. Now, did the positives really move over there? No, they did not really move over there. They were already there. What happened was that some of their electrons said, hey, I don't like these guys. I'm going to move over here. I don't like these guys either, but there's way more negatives over here, so I'm going to move over this way to get away from those negatively charged objects. So if you notice now, each of the individual pith balls are actually charged right now. They do have an excess charge, but if I pull this rod away, then what will happen is the negatives will go right back over, everybody will even themselves back out again, and I'll end up with 2 neutral objects. So in step 3, this is where the really important step occurs, and that is that I'm going to break contact with the 2 pith balls before I remove this rod. I definitely cannot remove this rod first. So let's draw the rod in there first. There's our negatively charged rod, and what's going to happen in step 3 is that I am going to separate them. And by separating them, I have now trapped the charges on there. Okay, so at this point, I no longer even need the charge rod because I've already separated them and they are trapped. So in step 4, all I need to do is to take away that. I take away the charged rod, and now I have 2 charged objects. And what's really even better about these objects is that they are equally charged. So this is equal but opposite charges. And this is how Coulomb did his work. He used the pith balls and used this technique of charging by induction, and by touching one pith ball to another, what would happen is that the charge will begin to separate. They'll spread out. They don't want to be near each other. These positives don't like being here, and these negatives don't like being here either. They don't want to be near other negatives, and they don't want to be near other positives. So he was able to create, even though he couldn't measure the charge, at the time that he was doing his work, he could not measure the charges easily. It wasn't easy to do. But what he could do is use charging by induction to create 2 spheres that were identically charged. And then if he wanted to create spheres that had different amounts of charge, he could do that through the last process, which is called conduction. Now, in conduction, it's not usually considered to be a real method of charging because if you notice one thing about these first 2 methods of charging, I started with neutral objects. Okay, I had all neutral objects, and somehow I managed to get the objects to be charged, right? And I always got 2 charged objects. I always got 1 positive and 1 negative, 1 positive and 1 negative. That's the way it works. That's because of conservation of charge, which is an upcoming video. I always get 1 of each. Conduction is a little bit different because I have to start with an already charged object. So let's say, for example, that I have that pith ball right here that has 4 positive charges on it. Okay, now let's say I want to have a pith ball that has half the amount of charge. How would I get a pith ball with half the amount of charge? Well, what I would do is I would bring in another pith ball and I would put them in contact with each other. Now, when I put the two pith balls in contact with each other, what's going to happen is, remember, these positives, they don't like each other. They want to repel each other. So when I give them another option with an identically sized pith ball, what's going to happen is that some of the charges are going to move over there. Okay, now all I need to do is to separate them, and I will end up with two pith balls that each has half the amount of charge that the original pith ball had. I personally feel like this is a method of charging. You know, if you touch something that has charge, charge can move on to that new object, whether it's an insulator or whether it's a conductor, charge can move on there. And so I would consider conduction to be a method of charging, but it does require me to already have an object that's charged. And one thing that you'll notice about conduction is I don't get two different charges, I only get the same charge, right? So all conduction can do is to send the same charge over. I did not end up with two oppositely charged objects, as I did with induction and as I did with charging with friction. But for my purposes, I would consider conduction a way of getting an object to be charged.